Well, hello everyone. In this video, I'm going to try to answer a question. I do have uh, two header files in C++. The first header file is to create binary tree nodes, and the other one to create the binary tree itself. And I do have two text files that I'm going to read from. The first one, which is the binary tree 2, is a full binary tree, and the second one, which is binary tree 3, is not a full binary tree. I'm going to build a project that basically can handle binary trees in general, and then I'm going to create a method inside the binary tree header file to check if a binary tree is a full binary tree or not. So the first thing, I'm going to start with Visual Studio, and I am going to go ahead and create a new project. And this project, I'm just going to call it test full BT. Choose empty project. And inside the header file, I'm going to create those two header files. So let me just go ahead and new item. It's going to be a header file. And I am going to go ahead here and use the name of these header files, just like they are. So this header file is going to be called btnode.h. And then I'm going to create another one. The second one is going to be called binary tree.h. Right after that, I do have those binary tree, both of them are opened. And I'm going to go open those files that I have here, this one and this one. Let's go ahead and open with Notepad++. And I'm going to copy, this is the binary tree, so copy that and put it in the binary tree. And for the binary tree node, let's copy that and I'll put it here. Now, after I'm done with that, I'm going to go create a source file. And you can call it whatever you want. In this source file, I'm going to include some header files. Let's start with the most important one, which is the binary tree. Binary underscore tree, well, I think it's an uppercase T, .h. Remember, you have to put it between double quotations and you have to put the H. I'm also going to include some other header files I'm going to need. iostream, since I'm going to read from a file, I will need the fstream. I think, yep, that's it. And since we're dealing with strings, because this is what I'm going to be reading from the file, so I'm going to create the strings as well. Integer main, let's go ahead and have a screen holder. Pause, and then return is 0. Of course, I need to use the namespace using namespace std. Okay, now in this file, let's just go back to those two files. Now this, as I said, is a full binary tree. If you open it, this is basically going to look like. This file has been created already for you. It's been traversed in a certain way, so this will basically build a binary tree. If you want to imagine it, this is the root, this is the left child, and then those are the two children of this C here, and then you go right of this B, you get D, and you get those two null children, and then after that you go to the left, to the right, sorry, you get E, which is the right child of A, and then you go to left, you see G for E, 2 null, and F, 2 null. So this is a full tree. This one, it's a little bit different. I think one of them will have only one child here. The E basically have one left child. So this is not a full binary tree. What I'm going to do, I'm going to copy those two files. and I'm going to put them inside this folder. So I need to go to the project here, and I'm going to post the files in this area. Let me just try to build it before. Where is it? Here it is. Build a solution. I hope it's not going to complain about anything. Okay, so basically everything was okay. Let me just go and check the properties again. And here is the source file. I just want to make sure that I got. Yep, I think this is the right place for those files. If it's not, I will change it later. Let's close this folder here. Now, in this area, before I start working on the header files, what I'm going to do, I'm just basically going to create a binary tree. So, binary underscore tree. Now, since it's a template, so I have to specify what kind of binary tree. It's going to be basically string. And after that, I have to give it a name. I'll just call it BT. Now that's fixed. Now I need to start reading from a file. So I will say if stream. I'll call it N. That's the name of the object that I'm going to use to read from the file. Then after that, I have to put the name of the file. So let me just go. Why did I close that? Skip, cancel. What is this? So let's go ahead and use the name of this file. After that, I'm just going to change it to 3. So I'm going to run the file basically 2 times. One of them using tree 2 and the other one to use tree 3. Now after that, there is a function overloading. I'm going to read using the ifstream object that's connected to this binary tree text file, and I'm going to read it and store it inside my binary tree object here. Right after that, I'm just going to go ahead and check if it's full binary tree or not. Well, the function I'm going to create, it's basically called is full. So I'm going to go put the object dot is underscore full. Now immediately I think it's going to complain about this because I haven't created this function yet. Is null? No, it's not null, it's full. And here we go. I haven't created this file yet, so that's why it's complaining. The key here is very simple. What I'm going to do, I'm going to go to the binary tree, and inside this binary tree, I need to create 2 methods in the private section of this. So let's keep looking for the private. Well, here it is. So this is the area where I'm supposed to create 2 methods. Now you may ask, why 2 methods? There's a simple reason for that. Let's just create them and I'll explain. What are they? The first method, again, both of them is going to be called is full. So I'm going to have an overloading function, bool, as the data type, because it's going to check is underscore full. And the first one, I'm just going to make sure that no change should be applied to any of the data. And the second one, bool, is underscore full. I'm going to pass the root here in this area. So I have to go ahead and type constant BT, it's an object node, NOD. What data type? Well, again, it's a template, so I'm not sure about what data type it is. What else do we have to put here? It's, again, we know it's a pointer. And then after that, I'll just call it local root. So I just need to go ahead and make sure what was the data type called in this definition. So it's basically item type. I believe that's what it's called. So I'm going to copy this, and I hope I don't. Where is it? Here it is. So it's going to be in this area. And here we go. So this is the two definition methods that I actually added to my header file. The first one is full with no arguments here, and the second one, I do have one argument, which is basically what we call the local root. The idea here is basically I can take this one away if I want and just keep this one, but this basically means when you're going to come here and call the function, you need to pass bt is full and you type bt again, which doesn't make that much of sense. So what I'm going to do, I'm going to take that away, and when I'm going to call this function here, basically I'm going to jump to this function, and the implementation of this function, basically what I'm going to do, it's basically going to call this function with the argument. That's the whole point here. The whole point here is the work that's going to be applied into this function. That's basically what we're going to actually solve the problem. But what we need to understand here, this function is going to be recursively called, and every time you call it, you're going to go and move from one node to the other. You're just going to start with the main root, and then you go left, and you go right, you go left, you go right. You scan, basically you're going to scan the whole tree. And every time you call the function again, you're going to pass a new child until you find there's no more childs to be checked. So if I want to summarize what I just did, I created this whole project. I added those two lines to the header file binary tree, and most importantly, this is my main function, which is basically a very simple function. I created a binary tree object, and then I created the file stream, a file stream. I connected it to a text file that I know for sure exists, and this is why I'm not having any tries here to make sure if the file does exist or not. This is not my point right now. After that, I'm using this object to read the information from the text file and store them inside the PT object. After that, I'm just checking if it's full or not. Now that I have the prototypes for those two methods, I need to go to the implementation. So let's start with the easy one. I'm going to copy this one. I'm going to go to the bottom of my file. Let's see here. Where am I supposed to create it? I can create it here in this area. Of course, I need to add a lot here, but let's just start step by step. This is a template, so we need to start with the keyword template. I think I misspelled it. T-E-M-P-L-A-T-E. Okay, now since it's a template, you have to tell me what data type do we have here. So there's two options. You can use the word class, but we try to avoid using the word class because we know the word class also has a different meaning. So there's another option, which is basically type name, and I'm going to use the same type name that I used. Okay, this is not easy to find it every time, so where is it? Public, protected, private. Here it is. So this is the type name that I'm using. That's one of the difficult part, is the size of this header file. So template bool, that's a data type, is full. Let's see here. Here, before we do this, we need to put the name of the class, which is binary tree. And then after the binary tree, again, you have to type. Okay, and I think I am done with the signature. Yeah, that's the difficult part here. That's one of the parts that I don't like about templates, even though they're really, really good tools. But the definition of the template is way too long. Template, and then you specify what you're going to be calling the data type. the return data type, and then the name of the class, and then you have to put again the type that you're using, which is basically going to be similar to this one, then the name of the function, and then you're done. I think I'm missing a semicolon somewhere. Yep, here. So, not semicolon, sorry, double colons here. Now that I have this one, all I have to do is to call the function well, that basically means we have a problem here as well. Okay, let's go back here. All I have to do is now to call the function is full. You can call it this way, or you can use the keyword this, and then you just type root. And it has to return something because it's a bool, so boolean. And I'm done with this function here. Let's hope. No, this is not working. Let's see here. Overload. Okay, I think after I'm done. Oh, wait a minute. I cannot put it as a private because if it's a private, then I don't have access to it. Lovely. Let's go ahead. Put it under protected, I think. That's the. Yeah. It should be. One of them should be. I made a mistake. I'm going to fix it right now. Again. This function here, I can keep this one private. That's not a problem, but this one cannot be private because if it's private, you will not have access to it here. I have two options. I can put it protected or I can put it to be public. I am just going to go ahead and create it as public. So let's go ahead here and define it here. This should take the 0 away. Okay. Now that this part is done, I need to get this part done. What I'm going to do, I'm going to copy this just like we did before. I'm going to go all the way down and put it underneath the first one that we just created here. This basically means I can copy this part and replace this bool here. And let me take this full away. And this is even longer. Again, template, type name, whatever the type name you chose to go with, item type, return to the type name of the class. The type name again is full. The difference here is that we have a local root here. Okay, so the idea here is to check recursively. Now, we need to have some definitions before we start. The first definition, if the tree is empty, that's basically a full tree. That will be number one. Number two, if you get to a node, and that node basically has no left child or no right child, that basically means you'll return true as well. If you pass the first two tests, you're going to have to go and call the function again. If you find it, basically, if you get to a point and you find that it's not a null, the root is not null, that it's not an empty tree, and then if you get to a point where if the node was leaf, basically it has no right child and no left child, that's where you're going to return true as well. And then if those two cases are not true, basically you have to go and check if the node has a left child and a right child. If that's the case, remember this, if that's the case, immediately you're going to have to call the function is full again with an if statement that you're going to have the if statement check the left child and the right child. But most importantly, we're going to have to call the return statement again where we're going to call is full tree for the left child, is full tree for the right child. And for both of them, you're going to use the AND operator. If both of them return true, then you're going to return true. If you did all these scans and you passed them and never got a case to return true, that basically means you got a not full tree. So what I'm going to do, I'm going to start with this, a very simple test. If root equal null, What do I do if that's the case? Return true. That's my first test. Or let's call it the base. Now, we're going to have another if statement. And I'm going to say if, and look at this. This is very important. Root, and I need to get the left. If the left equal null, and root to the right also equal null, you're going to return true as well. So I got those two base cases. Now the last case I'm going to check, and I'm going to say if root to the left. It's not returning null. And root, this is very important, both of them, to the right. I don't even have to test anything because, again, remember, this is C++. In C++, if it's not 0, 0 is false. If it's not 0, it's anything else that's true. Basically means I'm checking, do I have a left child and do I have a right child at the same time for the root that I'm testing right now? If that's the case, that basically means it's an internal node. And for that internal node, what I'm going to do, I'm going to say return. And this is, again, the key here. I'm going to have an AND operator, and I'm going to check if the left child is full and the right child is full. So is underscore full for the left child, and the same thing is full for the right child. Let me just put a space here. And again, how do I go to the left child? Well, root, and I'll just say left. Same thing here, root right. Okay, so I did all these tests. I test if it's a null, if it's a root. I test if it doesn't have a left child or right child, return true. And then I checked if the left child and right, if it has a left child and right child. I go to the left hand child and see if both of them are full or not. If I pass all these tests without getting a case to be true, basically I am going to have to come here and return false. Oops, okay, this should not be the case. I need to put this here. Why is it moving? Oh, because of the semicolon here. Okay, now that I'm done with this file, now remember this is my first function. It's a public, so you can have access to it. And here's my private function, which is the one with the argument, which recursively will be called is full for the left child, is full for the right child. Let's go ahead and run the code. Now remember, 2 is a full tree, so if I run it, oops, what are you complaining about, binary tree? Let's see here. Must return value? Oh, look at me. Return not. Well, sorry for that. Looks like it's going to work with no problems now. Come on, you're a good computer. Oops. There's something that he didn't like. Stack Overflow. Okay, let's see here. What is going on? What I'm going to do, I am going to stop this video right now, and I'm going to try to figure out what is going on, and then I'm going to come back and explain it. So hold on, don't leave. I am back. Now, let me just start with this. As much as I love programming, as much as I hate it sometimes. So, let me just show you what happened. Now, before I show you that, let me just stop for a moment to thank God for debugging. So what I just did here, I decided to debug my function here is full to try to figure out what did I do wrong. And boy, oh boy, I hope you realize that without the need to wait for that long time. Now, I started with the beginning and this is the end. And I decided, show me the data as I'm moving through the process. So I decided, well, root data, because this is what I'm using here, root, remember. And then look what's going to happen here. Return true, as I said before. Then check if it's left and child are null. Return true. Otherwise, if we have a leaf that has a left child and a right child, I did show me the data. So it showed me the data, and then I call the function here again. And let me just run it so you'll see what's going on here. I am just going to keep going. And I'm just going to show you before I get to the recursion part. You can see here I got A and B and E. Now, when I call it again, let me just go straight forward. And look what I just figured out. Oh, I'm getting it back again. So, again, I am just moving in a circle that will never end. So, let me stop at this point. And I was like, why is it doing this? Why is it calling the original root of the tree? And I just realized, why is that? Because I'm calling it here and I'm calling it here. Look at my mistake here and learn. What did I call it here? Local root. What am I using here? Root. I'm using the root of the tree. So recursively, I'm passing the root again and again and again. So the fix here is basically to choose the local root, copy that, and replace all the roots. That was my mistake. So I am going to fix it right now. And I should be good to go. Local root, and local root. I just had my coffee. I don't know how did this thing slipped away that easy. So I'm going to take this away. I don't need this C out anymore. Well, this was just take it as a good practice to use debugging tools, because again, in real life, this is your friend. This is your actually only friend in this C world, C++, or any programming language. So now let's go back here. I know for sure 2 is a full binary tree. I'm supposed to get 1, and here it is. So let me close this and close this. Now if I go in and put 3 here, and you'll see that I get 0. Okay,